Hello, this is Gabriel Barahona, and I am working with Curtis Jennings, and we are going to do a brief overview of our 7th update of Engi 460 final project. So first of all, we're going to do a brief overview of the abstract, and the paper and model presents a theoretical and applicable model of self-organizing robotic systems composed of local systems which are independent to each other and randomly seek spills within a manufacturing facility. This is based on the ants foraging simulation model, and these cleaning robots are randomly released into an environment in search for unwanted chemical residues. In a similar approach to the model, the robotic systems utilize a pheromone-like mechanism, and in our case this will be a sound sensor that will allow the robots to locally communicate with nearby entities of spill locations once one of them has detected one. Okay, and the main areas of the code which we will change, let us first go to ants forage and let's take a look at these obstacles. Since we are developing a manufacturing environment, we're going to try to simulate this manufacturing environment by changing the obstacles. Originally there were 2 long oval shaped circles, and just to show you an example, we changed these obstacles into small circles, and we are going to try to add squares and lines to simulate a workstation environment. So let's run this code, and as you guys can see, the obstacles are smaller, and then the interaction is different, and depending on the obstacles it will be harder or easier for these robotic systems to find the spills or the food pheromones in the ants foraging model. Another area which we will be changing is, if we can go here to ants foraging again, we are going to change the food location and the home location, and we are mainly trying to add another food pheromone to simulate another spill within the manufacturing facility. And here we initialize the grid with the home and food sites, and we are trying to add more food sites in order to simulate these spills.
Now we just want to quickly discuss the operational viability of the simulation versus real-time execution of, if we were to implement this into a manufacturing facility, how would it actually run in a manufacturing facility versus the simulation. When looking at the randomness and the speeds in the simulation, you can notice that they are very fast, and in respect to real-time execution, those speeds in the simulation are a little bit unrealistic. We can speed up the simulation and slow it down, and in respect to real-time, that is impossible. And the randomness in the simulation we can also control. And for robots in manufacturing facility, the randomness is quite uncontrollable, and which leads to a little bit different results. If we were to time the robots going and finding the spills versus the times that are recorded in a simulation. And the simulation demonstrates a concept that is, not to be used for timing purposes. Like I said, we can speed it up, we can slow it down. And so the simulation is really only a concept that we can demonstrate. So, and the evaporation constant within our simulation is also not realistic. We're using sensors for the robots, and we're not using an actual pheromone that in real life robots could sense using, say, like human senses or senses that ants in the ants foraging model could use.